Okay, in this particular question, we're going to look at an open market purchase in the Neoclassical model, and it's almost identical to the Keynesian model, except instead of assuming prices are sticky in the short run, which would make the short and aggregate supply curve flat, we're assuming the short and aggregate supply curve is upward sloping. So that's the only difference between this one and the one we did on the Keynesian model. Okay, so again, it starts out just like it did before. We have to build the demand curve for reserves and the supply curve for reserves. So to do that, we have to get the shock parameter, which in this case is negative 42.6. The reserve requirement ratio in this particular question is 1.1 or 10%. The checkable deposits is at $511 billion. The slope of the demand equation is 0.005. And so to calculate the intercept, you add required reserves, the product of these two, to the shock parameter, and you get 8.5. So the demand curve here is at 8.5, the intercept, and the slope is 0.005. The vertical section of reserves is the quantity of reserves in the banking system, which would just be $1,200 billion. And if the target for the federal funds rate is 2.5, the discount rate would be 3.5. And so the supply curve kinks at 3.5 at the discount rate. So let's just hit enter and see if we got everything right, and we do. Okay, so the equilibrium here is right there. We don't know what this rate is yet. We don't know what the equilibrium interest rate is, but we know that the discount rate is where the supply curve kinks, and the discount rate is at 3.5. This is the price of reserves, the federal funds rate. The quantity of reserves is denoted R. This is the demand for reserves, and this is the supply of reserves. Okay, we need to find, we know the equilibrium quantity is 1200. So we're going to plug this 1200 into this curve here. So we're going to plug 1200 in a demand curve, okay, to get the federal funds rate. So let's go ahead and close all this out. And over here, we're going to type equal 8.5 minus 0.005 times the quantity of reserves, which is 1200. And we get 2.5. So the quantity of reserves in equilibrium is 1,200 billion, and the federal funds rate in equilibrium is 2.5. And the federal funds rate is equal to its target. So let's go ahead and enter. Okay, good. Now we're moving on. Now assume the market for money. So this is, you can think of reserves as bank money. Banks can make loans with it, banks can hold it, or banks can lend it out, right? They can lend it out. So you can think of reserves as bank money. And the interest rate in this market is what banks pay each other when they borrow from one another, right? Down here is the market for money. And you can think of this as the money that is being used by firms and individuals. And you can think of the nominal rate of interest as like the prime lending rate. And the prime lending rate is usually always greater than the interest rate that banks charge themselves, okay, when they're lending amongst themselves. Okay, so to label this diagram, we have the money supply, mostly currency and checking deposits, and then the money demand. We have the equilibrium, and it looks like the equilibrium interest rate is about 3, so we expect this to be about 3. The quantity of money in equilibrium is 2190, right? So all we're going to do is we're going to plug 2190 into this equation to get the interest rate that firms, prime lenders, or prime borrowers would pay lenders, right? So we plug that 2190 into that equation, we get the prime lending rate. So we're going to close this. Oh, and the price of money is the nominal rate of interest, and the quantity of money is just M. So let's close that out. The equilibrium quantity is T190. And we're going to go over here. We're going to type equal 13.183 minus 0.00047 times the quantity of money, and the quantity of money is 2190. So we're plugging the 2190 into the nominal interest rate equation, and we get 2.890. That's the equilibrium. Okay? And we'll hit enter to see if we got everything right. And it looks like we do. Okay, now, suppose this is the state of the economy, right? GDP is less than potential. So we're in a recessionary gap, where unemployment's high and GDP is low. Okay? And so to find real GDP down here, the 13.533, we set these two equations equal to each other, and we solve for the y. Okay, that's what we did, and I give it to you, 13.533. Okay, so once we have the GDP level, I can plug this GDP level into either one of these equations to get the price level. So let's close that out. Okay, down here, I'm going to type equal 428 minus 15 times the GDP level, 13.533. I get a price level of 22.5 or 225.005. And then I can do the same thing with the supply curve. Multiply that slope by 13.533, and I should get something about the same. To 2 decimal places, I get 225.01. Let's just try 225. It's just a round off error. That's the reason why they're not exactly equal. We'll just do 225. Okay. So price level is 225. And again, we've rounded off the real GDP level, so that's why the price levels aren't exactly equal. But if we go to 2 decimal places, or 1 decimal place, we'll get 225.0. Okay? The output gap is the difference between this real GDP level and what it should be. So the gap is equal to 13.533 minus 14.923. So the gap is a negative 1.390, which means because it's negative, we're in a recessionary gap. Okay? Because the unemployment rate is greater, which is the case here, is greater than the natural rate of unemployment. The economy is said to be in a recessionary gap. Okay, cool. Now to close the above gap, the Fed conducts an open market purchase, OMP, to lower the federal funds rate. And the Fed wants to lower the federal funds rate to 1.5. Okay, assuming the open market purchase is equal to $200 billion, reserves will increase from what it was, I think it was 1,200, plus the 200 billion. Okay? So that would be 1,400, right? 1,400. So the vertical section of the new reserve supply curve would be 1,400. And since the Fed's federal funds rate target is 1.5, the discount rate, which kinks the supply curve, reserve supply curve, would be at 2.5. Now, at this new equilibrium down here, right, at this new equilibrium down here, the quantity of reserves equals that 1,400. Okay? So this would be 1400. Then we got to plug this 1400 into the reserves demand equation. And the reserves demand equation is right here. At 1200, the federal funds rate was 2.5. But at 1400, what is it? It's 1.5. So the federal funds rate is 1.5. Okay, so let's just hit enter to see we got everything right here. Okay, so let's go ahead and graph it. Okay, the new supply curve for reserves is here. The equilibrium interest rate is 1.5. The old supply curve is right here. This demand for reserves did not change. The federal funds rate is a price of bank money called reserves. R is the quantity of reserves. And the original equilibrium was right here. So this, the open market purchase of that amount lowers the federal funds rate. Okay? So we'll go ahead and close that out. Okay, so the open market purchase was $200 billion, right? How does that affect money? The money that firms and consumers use. Okay, with the money multiplier set to equal at 2.05, the money supply increases by the amount of the open market purchase times the multiplier. Okay, so money's going to increase by $410 billion. So this is the increase in the money supply. What was the money supply originally at the black line? Well, at the black line, the money supply was 2190. So we're increasing from that level by 410. So this would be 0, carry the 1, add 4, so it should be 2600. Okay, now, so we're at this point down here, right? The prime lending rate, the nominal value of the prime lending rate, dropped to this value, right? It was higher at around 3, right? Probably just under 3. How do we find this new interest rate? Well, we're going to plug this new value of the money supply into the original money demand curve. So the money demand curve that hasn't shifted yet, 13.183 minus 0.0047, we're going to multiply that by the new quantity of money. Not the old quantity of money, but the new quantity of money. And the new quantity of money is 2600. So the interest rate drops all the way down to 0.963. Okay? The old interest rate was 2.890. So this is what the nominal rate of interest was in the market for money, and this is what it is now. Okay? So let's go ahead and enter here. Okay. Assuming the monetary policy works as intended, which is it's supposed to move aggregate demand from here to the red curve, we're going to show how it affects the neoclassical model. If inflation expectations are constant, remember the nominal rate of interest that firms and prime consumers and prime businesses pay lenders, it is equal to the real rate of interest plus expected inflation. Okay? So the nominal rate of interest fell to 0.963, we're holding expected inflation constant. That's going to reduce the real rate of interest, okay, by the same amount. So the real rate of interest was 2.890. The new rate of interest is 0.963. So it's just a difference in those two. So the real rate of interest will fall by the same amount that the nominal rate of interest falls by if inflation expectations are constant. Okay? Which increases investment expenditures and increases exports. And all this will increase aggregate demand. And the price level is going to rise from this low level around 220 up to this level of maybe 250, right? So price level is going to increase. The price level increased, and real GDP increased, and unemployment declined. Oh, maybe increases. This increases aggregate demand. How about that? Yeah, it increases aggregate demand. Real GDP increased from here to here. Price level increased too along the short and aggregate supply curve, and unemployment declined. So in the neoclassical model, monetary policy theoretically closes the recessionary gap, but it leads to recession. In the Keynesian version of the model, it doesn't have any effect on inflation or prices because prices remain constant in the short run, but the monetary policy closes the gap.